Motor insulation classifications specify the maximum temperature the insulation can withstand without degrading. Common classifications include Class A, Class B, Class F, and Class H. Class A has a temperature rise above ambient of 40 degrees Celsius or 72 degrees Fahrenheit. Class B is a temperature rise above ambient of 80 degrees Celsius or 144 degrees Fahrenheit. Class F has a temperature rise above ambient of 105 degrees Celsius or 221 degrees Fahrenheit. Class H has a temperature rise above ambient of 125 degrees Celsius or 257 degrees Fahrenheit. When interpreting insulation class and temperature, the example of 40 degrees Celsius ambient continuous in the example refers to Class F insulation. This means that the motor is designed to operate continuously at an ambient temperature of 40 degrees Celsius or 104 degrees Fahrenheit. The maximum allowable operating temperature of the motor is the temperature rise above ambient specified by the insulation class plus the ambient temperature. For example, Class F insulation has a 105 degrees Celsius or 221 degrees Fahrenheit temperature rise plus a 40 degrees Celsius or 104 degrees Fahrenheit ambient temperature. This equals a 145 degrees Celsius or 293 degrees Fahrenheit maximum allowable operating temperature. Consider this example calculation. A 7.5 horsepower 3-phase motor has 8.8 amps at 460 volts. Full load amperage is 10.2 amps and the ambient temperature is 24.2 degrees Celsius. To calculate the temperature, firstly calculate the watts, which is voltage times current times the square root of 3. This is 460 volts times 8.8 amps times the square root of 3, which equals 6 kilowatts. Secondly, calculate the temperature rise, which is power times the load factor, divided by the insulation class. The load factor is the full load amperage divided by the operating current, which is 10.2 amps divided by 8.8 amps, which equals 1.16. The temperature rise is 6 kilowatts times 1.16 divided by Class F. This equals 69.6 degrees Celsius or 157 degrees Fahrenheit. The motor operating temperature is the ambient temperature plus the temperature rise, which is 24.2 degrees Celsius plus 69.6 degrees Celsius, which equals 93.8 degrees Celsius or 201 degrees Fahrenheit. In general, motors should operate below their maximum allowable operating temperature. Motors operating at or near their maximum temperature may experience reduced lifespan, increased risk of failure, and decreased efficiency. Acceptable operating temperature ranges for motors depend on factors such as load, ambient conditions, and insulation class. As a rule of thumb, it is generally considered acceptable for motors to operate up to 15 to 20 degrees Celsius below their maximum allowable operating temperature. In the given example, the motor is operating at 93.8 degrees Celsius, which is well below its maximum allowable operating temperature of 145 degrees Celsius. Therefore, it is operating within an acceptable temperature range. Consider these additional points. The load in the motor can affect its operating temperature. Heavily loaded motors will typically run hotter than lightly loaded motors. Ambient conditions can also impact motor temperature. High ambient temperatures will result in higher motor operating temperatures. Proper motor ventilation is essential to maintain optimal operating temperatures. Blocked or clogged air vents can restrict cooling and lead to overheating. When determining motor operating temperature, consider these factors in more detail. Firstly, motor load. The load on a motor is the amount of work it is doing. A motor that is heavily loaded will draw more current and generate more heat than a motor that is lightly loaded. The load on the motor can be expressed as a percentage of its rated horsepower. For example, a 7.5 horsepower motor that is operating at 5 horsepower is operating at 67% load. Secondly, ambient temperature. Ambient temperature is the temperature of the air surrounding the motor. A motor that is operating in a high ambient temperature will run hotter than a motor that is operating in a low ambient temperature. The ambient temperature should be considered when selecting a motor for a particular application. Thirdly, insulation class. The insulation class of a motor is a measure of its ability to withstand heat. Motors with higher insulation classes can operate at higher temperatures without being damaged. The insulation class of a motor is indicated by a letter, such as A, B, F, or H. Fourthly, ventilation. Proper motor ventilation is essential to maintaining optimal operating temperatures. Motors that are not properly ventilated can overheat and fail. Motor ventilation can be improved by cleaning the motor's air vents and ensuring that the motor is not located in a confined space. Fifthly, altitude. Altitude can also affect motor operating temperature. Motors that are operating at high altitudes will run hotter than motors that are operating at low altitudes. This is because the air at high altitudes is thinner and less able to cool the motor. Sixthly, voltage. The voltage supplied to a motor can also affect its operating temperature. Motors that are supplied with a voltage that is too high or too low can overheat and fail. The voltage supplied to a motor should be within the motor's rated voltage range. Seventh, frequency. The frequency of the power supplied to a motor can also affect its operating temperature. Motors that are supplied with a frequency that is too high or too low can overheat and fail. The frequency of the power supplied to a motor should be within the motor's rated frequency range. Eighth, duty cycle. The duty cycle of a motor is the amount of time that it is operating compared to the amount of time that it is idle. Motors that have a high duty cycle will run hotter than motors that have a low duty cycle. Ninth, motor age. The age of a motor can also affect its operating temperature. Older motors may have insulation that is degraded, which can cause them to run hotter. 10th, motor condition. The condition of a motor can also affect its operating temperature. Motors that are damaged or have worn parts may run hotter. By understanding these factors, you can better assess whether a motor is operating within acceptable temperature limits. When troubleshooting motor temperature problems, consider these steps. Firstly, check the motor's nameplate. The motor's nameplate will provide information about the motor's rated voltage, current, horsepower, and insulation class. Secondly, measure the motor's operating temperature. The motor's operating temperature can be measured with a thermometer or a thermal imager. Thirdly, compare the motor's operating temperature to its rated temperature. The motor's operating temperature should be below its rated temperature. Fourthly, check the motor's ventilation. Make sure that the motor's air vents are clean and that the motor is not located in a confined space. Fifthly, check the motor's load. Make sure that the motor is not overloaded. Sixth, check the motor's voltage and frequency. Make sure that the motor is being supplied with the correct voltage and frequency. Seventh, check the motor's age and condition. If the motor is old or damaged, it may need to be replaced. By following these steps, you can troubleshoot motor temperature problems and ensure that your motors are operating safely and efficiently.